Hello and welcome to the video. In this video, I'm going to be going over my new design and what I'm going to be doing to machine and manufacture it. First off, these are my two prototypes of the design I'm going to be working on. They're made out of titanium and you can see the basic idea. The name of these knives are the Voltaic, and I currently have two models in front of me right now, one of which is made out of a 2-piece assembly and one of which is made out of a 4-piece assembly. I'm going to end up going with the 4-piece assembly because it is a bit easier to manufacture and machine. The Voltaic is made from grade 5 or 6AL-V4 titanium. They are made out of 4 little pieces of this titanium. It is 3/8 by 5/8 by 6 inches long. This is the general layout I'm going to be using for my pallet system. I'm going to have on the right where I put all my raw material, and then on the left I'm going to have a sub pallet where I do my op 2. First things first, I need to clean the mill out. I spent some time machining foam the other day and it's a big mess, so let's get on with a time lapse and get this mill cleaned up. Now that the mill has been cleaned up, it is time to start the machining process on my Pierson mini pallet system. I start by installing the pallet onto the pallet system, and my next step is to face it. I make sure that my tool setter has enough clearance so I won't end up running into that. I then go ahead and start my program for the pallet. Now that the pallet is done machining, you can see what the overall design is and how I intend to hold things and fixture them. I start by doing a pop test on the important pin locations, and you can hear that they are very nicely fitted. And as you can see, the rest of the pallet has a very nice finish and overall looks pretty fantastic. Now that the pallet is off the mill, you can see it a bit better and just how it looks. The next step is going to be to tap the holes in the pallet. I did not machine tap them because I was a little scared of that, although I do figure out rigid tapping a bit later in this process. Tapping by hand takes a bit more time, but it is a lot more reliable and you're much less likely to break a tap off in your pallet and ending up having to scrap it. Now that all the tapping is done, I'm going to do a test fit with the Mighty Bite knife edge clamps that I am using to hold my stock. Everything goes in smoothly and tightens properly. Okay, now all the tapping is done and it is time to install the rest of the clamps. Now I'm doing the first test install of my material just to make sure everything is working properly. I go ahead and tighten down the clamps and see how well it holds. Now that everything is tightened, I go ahead and try and pull it out, but I cannot move it at all. Now that all that is done, I'm going to drill out some of the holes I made undersized because I forgot what size drill bit I would end up needing, so I just went ahead and made them undersized. I am drilling out the hole for a 1/4 by 20 inch screw. Now that I'm done drilling those out, I'm going to go ahead and tap all of those 1/4 by 20 holes. Then I go ahead and test the fit with a 1/4 screw. It's a little tight to start with, but it loosens up and gets nice and easy to screw in and screw out. Now that the first pallet is done, it is going to be time to move on to the second pallet. As you can see, everything's finished, all the holes are correct, all the tolerances are final, and everything is tapped. And now it's time to start working on the sub pallet, which will go on this side. I start off by tearing down the machine and taking off the Pierson mini pallet system so that I can get something in to hold the bigger plate I'll be using. I'm using some Saunders MachineWorks mod devices that I've never used before, so I had no idea how to install them and spent quite a while just kind of messing around with things before finally looking it up and following the tutorial. I eventually figured it out and got it in, and it held it very securely, and they worked fantastically. Now it's time to start machining it, so of course I start off by facing it off and getting that surface nice and flat. You can see here that the facing end mill left a very nice and shiny finish. I then go ahead and pick up an 1/8 inch end mill, and it starts the boring process for all the screw holes and the location holes. Now you can see the first op on the pallet is finished, and the tolerances on everything are very good, and there's a nice pop fit. I then go ahead and take the pallet out of the mill to start working on the next process. Because I can't reach both sides of the pallet in the Saunders machine vise, I have to drill out these holes for the screws. They are not a very accurate dimension, so it doesn't particularly matter, so I just grab the drill bit with the correct head size and make sure the drill bottoms out at the spot where I wanted it to go to. I then go ahead and swap out my drill bit for a 1/4 inch reamer to clean up any burrs inside of the 1/4 inch holes and make sure that they are at the correct final dimension. Here you can see what everything looks like once the holes have been countersunk. It's now time for me to tear down the mill once again, so I go ahead and take out the Saunders mod device, which worked really well, and I go ahead and put back in the Pierson mini pallet system. The Pierson mini pallet system is a really easy install. The 4 holes are made for my table, and I just go ahead and put it in, and it's in the exact same spot every time. I then locate everything in with my probe, and everything's always exactly the same. Now that I'm done with the main pallet and op 1 of the sub pallet, it is time to go ahead and put them together to get op 2 for the sub pallet done. Make sure everything is very clean when putting them down because you don't want anything to be lifted up, and then line up your holes and just screw everything in. I go ahead and put in my 2 locating pins to make sure everything always stays the same. I ended up making 4 locating pin spots, but you only ever use 2 when locating, so I just made those in case I messed something up. I then go ahead and put in all 4 screws. I likely won't run the pallet with 4 screws in it, but to machine it and remove a lot of material, I'm going to put all 4 in to make sure nothing moves or shifts. Now that everything is put together, you can see how well it all holds together and that everything should be exactly the same each time. Now it's time to machine this. So I start by installing my pallet system like normal and making sure to get my Z height correct to machine everything. It's now time to run the Op2 program. As always, I start by facing off the pallet, and thankfully I did not hit any of my screws, although this wouldn't have been much of an issue. I again checked to make sure I wasn't going to run into the probe while machining this. The facing is now done, and everything is like a mirror and very shiny. The next step in the process is to rough everything out with a 1/4 inch end mill, and I just go around the dimensions and get the pallet made to size and rough everything out. You can see here just how much material it removed and what the final pallet is going to end up looking like. Now it's time to go in with a smaller 1/8 inch end mill and get into all the areas that the 1/4 inch could not. You can see that all the final dimensions are done and the pallet is basically done. I'm just going to put a small chamfer on everything so nothing is sharp. Now that the chamfer is done, the pallet is now finished and ready to move on to the next step. I go ahead and clean off all the chips from the mill because I did machine quite a bit of aluminum and it does make quite a bit of a mess. I go ahead and take the pallet out so that we can have better access to it and see exactly how well it did. As you can see here, this is what the finished pallet looks like. I'm going to go ahead and take it off so we can see all of the sides. Now that the pallet is off, I'm having a bit of trouble getting this 1/4 inch pin out because when I faced it, it created a small burr inside of that hole, so I end up cleaning that up later. But you can see this is how the pallet looks now that it is finished. And you can see the handles go on there for the second operation of machining the top faces. The sub pallet I just machined was actually completely wrong. I ended up machining the wrong side. The pallets are able to go on to the main pallet upside down, and I didn't check how I put my sub pallet together on the Pierson, and so I ended up machining it upside down and ended up having to remake it. When I first machined Op 1 for the first pallet that I messed up, I made 2 because when you run Pierson pallets, you always run 2 pallets because it's the most efficient. And so I ended up making 2 of them, and as you can see, I just skipped ahead in that machining process so you can see the new finished one. And this one, all the holes line up correctly with where they are actually supposed to go. The reason for the holes on the bottom is because the second operation of these knife handles are held on by threaded holes inside of the titanium that hold it to the pallet so I can have access to all these sides. And when I machined the first pallet, I machined it upside down, and so the holes were all in the wrong spot and did not line up. When I designed this, I intended to use 4 screws in the system, but I'm only going to end up using 2 because that's all I need for my reduced feeds and speeds to create less load, and it also makes it a lot easier to not have to take it out in the middle of the process and remove some screws from the middle. This is what a fully stacked pallet would end up looking like, except there would be 2 more handles on the left side. Thank you for watching the video. I hope you enjoy. In the next video, I'm going to be running the first handles, and so make sure to come back and see that. If you stuck around this long and enjoyed the video, please consider liking and subscribing.